Hello everyone, welcome to this online lecture class on the chemical reaction engineering subject. I am Anuj Chaturvedi, lecturer chemical engineering from the Department of Technical Education. So before going into the aspects of chemical reaction engineering, let us first discuss that what is chemical engineering. So it's basically a multidisciplinary branch of engineering that combines the natural and the experimental sciences, and that will involve basic chemistry and physics and mathematics too. Plus the economics is also involved, how to design, develop, produce, transform, transport and operate the processes and the industrial things that actually are turning the raw material into the valuable products. Many of the processes within the chemical engineering involves several chemical reactions. Chemical engineers then translate these chemical information and reactions to a large scale production and the various designs. So if I talk about more precisely what is the work of a chemical engineer, so that will involve the designing, manufacturing and operating the chemical plants and machinery for carrying out the large scale industrial chemicals, biological and some related processes. These chemical engineers, and we can say that we chemical engineers also develop new or adapted substances for a wide range of product. So more precisely, if I talk about chemical engineering, it involves two processes, that is the unit operations, which are the physical changes, and unit processes, that are actually the chemical changes. So if I talk about this subject, chemical reaction engineering, we will be more precisely talking about these chemical changes only. And the physical changes, the subjects that we study that involve these physical changes or the unit operations are as further. You can see that the heat transfer operation that includes the conduction, convection and radiation. Various mass transfer operations are there, for example distillation, diffusion, drying, etc. We also study the fluid mechanics subjects, which is actually the momentum transfer operations and the mechanical operations that we study in the first year itself of our diploma curriculum. So let us just see this typical chemical process. So it involves basically the transformation of the raw materials into the final products, as you can see with this block diagram. So first of all, there is a pre-treatment step, which is the physical treatment step. After that, we have a chemical change, which involves a chemical reaction, and furthermore, the separation of the chemically produced products. So those are separated, and the ones which are not reacted, or I can say the unreacted species, are then recycled back to the first step of physical treatment. Now in this middle step, that is the chemical treatment step, our chemical reaction happens. So what is chemical reaction? If I just talk about what is chemical reaction in the fundamental terms, so it is basically the changes of a of some molecules or bonds into some new bonds. Okay, so the product is formed when the reactants are reacted away. So this is what a typical chemical process is. Now for carrying out these chemical reactions, we have these reactors. So what a reactor can do, we will give some input to the reactor, as you can see with this schematic. So what a reactor will do, it will take the inputs, it will arrange the chemical reaction, the chemical reaction will take place, and the final products are formed in the form of output. So if I talk basically about this reactor, how should I judiciously choose the reactor? What are the things that I need to consider while choosing or selecting a reactor is these two things. As you can see, first one is the contacting pattern. How am I going to contact the two reactants? Is it a batch? Is it actually a batch reactor, or a continuous reactor? Are they going to mix lately, or the reactants are going to mix abruptly? Okay, these are the things that we need to consider. And the second thing that we need to consider is the kinetics. Okay, so what are kinetics is, this is basically, the kinetics is the topic of today's class basically. So what do you mean by a kinetics? So kinetics will tell you the speed of the reaction, how fast or how slow the reaction is going to take place. So if the reaction is not so fast, what are the parameters that we need to change, or what are the parameters that we need to tweak, okay, change, so that we can carry out the reaction? Okay, the temperature or pressure, what are the parameters that can be changed so that the reaction can be carried out on a desirable rate? Okay, so this is what kinetics is all about. Now, what will be the performance reaction? For any reactor, we have the performance equation, that is the relationship between the input output kinetics and contacting. So the output, that is the product, that will depend on the input, and the rate of reaction, that is the kinetics, and the type of reactor that is used for contacting. Okay, so that's the third one. So with this expression, with this performance equation expression, we can compare different designs and conditions and find what is the best setup for carrying out the reaction on a large scale for larger units. Now let's talk about the reaction rate. So what is the reaction rate? What is the reaction rate expression basically? So if the rate of change in the number of moles of any component due to the reaction is dNi by dt, that is the change in the number of moles of ith component divided by dt, that is, so when we are dividing any term by the time step, it is actually giving us the rate expression. Okay, so then the rate of the reaction in various forms can be defined as follows. So if it is based on the unit volume, कि हम अपने रिएक्टर में कितनी वॉल्यूम है उसको बेस बना के अगर चलते हैं, so the first one that you can see, the blue one that you can see here, this is the rate expression that we will be using. Okay, moles of I formed, that is change in the number of moles of I, that is dNi, divided by the volume of the fluid, okay, volume of the reacting fluid, divided by time step is going to be there, time step रहेगा because यहाँ पर rate की बात हो रही है. Second बात करते हैं based on the unit mass of solid in fluid solid system. So it will, अगर हमारे पास कोई हेट्रोजीनियस रिएक्शन हो रही है जिसमें हमारे पास कोई एक रिएक्टेंट सॉलिड है, तो उस केस में हम लोग मास ऑफ सॉलिड को एज अ बेस लेके चल सकते हैं. या अगर हमारे पास कैटेलिटिक रिएक्शन है, दैट इज हमारे पास एक कैटलिस्ट है जिसके सरफेस पर रिएक्शन हो रही है, तो उस केस में हम यहाँ पर मास ऑफ सॉलिड जो भी हमारा कैटलिस्ट है उसका मास लेके चलने वाले हैं. थर्ड तरीका है जिससे हम डिफाइन कर सकते हैं, बेस्ड ऑन द यूनिट इंटरफेशियल सरफेस in two fluid systems or based on unit surface of solid in gas solid system. मतलब जो कॉन्टेक्टिंग सरफेस एरिया है हमारे दो फ्लूइड्स का या सॉलिड लिक्विड का, उसके बेस पे हम लोग रेट ऑफ रिएक्शन को डिफाइन करेंगे. ठीक है, सो फ्रेंड्स आपको ये बेसिकली याद रखना है कि रेट ऑफ चेंज ऑफ द नंबर ऑफ मोल्स ऑफ एनी कंपोनेंट डिवाइडेड बाय एनी बेस. अब ये बेस कोई भी हो सकता है, वॉल्यूम ऑफ फ्लूइड हो सकता है, मास ऑफ सॉलिड हो सकता है, सरफेस एरिया ऑफ द कॉन्टेक्टिंग हो सकता है, या फिर हमारा वॉल्यूम ऑफ सॉलिड भी हो सकता है. ठीक है, तो उस बेसिस पर ही हमारे रेट ऑफ रिएक्शन की यूनिट भी डिफाइन होती है. लेट्स मूव फर्दर. सो वन मोर बेस इज द यूनिट वॉल्यूम ऑफ द रिएक्टर. मतलब पहले हमने लिया था कि वॉल्यूम ऑफ द रिएक्टिंग फ्लूइड्स, और यहां हम बात कर रहे हैं वॉल्यूम ऑफ द रिएक्टर की, जो टोटल वॉल्यूम रिएक्टर की हम लेके चलने वाले हैं. तो इन्हीं सब अगर रेट्स को हम कंपेयर करते हैं तो ये हमारे पास एक कंपैरिजन आ जाता है जो आप देख सकते हैं. इस तरह से हमारे पास अगर एक पैरामीटर है, जैसे हमारे पास अगर वॉल्यूम ऑफ फ्लूइड है और रेट है RI है, और हमारे पास दूसरा मास ऑफ सॉलिड पे बेस्ड भी रेट है, तो हम मास ऑफ सॉलिड निकाल सकते हैं. या हमारे पास मास ऑफ सॉलिड है तो हम रेट उसके बेसिस पर भी निकाल सकते हैं। तो इस तरह से हम रेट इक्वेशन को डिफाइन करते हैं। आई होप आपको ये लेसन अच्छा लगा होगा। हम इसके बाद और कई सारे लेक्चर्स इस सीरीज में आने वाले हैं। सो कीप अपडेटेड ऑन द यूराइस प्लेटफॉर्म एंड वी विल बी अपलोडिंग more and more tutorials for you guys. Thank you all for joining in.